Hello, I am Lasma from Staff Technica, and today I will talk about the accuracy of the CO2 concentration measurements using ARNet4 sensors. Here I have ARNet4 sensor. The CO2 concentration measurement is represented by the large number in the center of the screen. Right now the reading says 832 parts per million. To get a meaningful information about any measurement, the reading on the screen alone is not enough. One of the parameters that characterizes any measurement is its accuracy, and today we will talk about it right now. Now I will open the datasheet of ARNet4 sensor. I go to the ARNet webpage, open Products, choose ARNet4, and scroll down the page until I see ARNet4 Home Datasheet, and I click on that. I am interested in the table about the sensor performance, and here I am looking on the accuracy information for the CO2 measurements. The information here says that the accuracy is 3% of the reading, and I need to add 30 parts per million. But here are also two footnotes. Let's read them before we proceed to the calculations. The third footnote says 95% of the sensors measure within these typical limits in equilibrium state at the time of sale. For evaluation of the total measurement error, long-term drift has to be taken into account. So, to the 95% of sensors, the given accuracy expression holds true. Also, due to the long-term drift, this accuracy relation is true when we first use the sensor, but after a year it must be corrected. However, for CO2 concentration measurements, if a drift occurs, calibration feature of the device should be used. Let's go to the next footnote, where I will focus on the CO2 concentration measurements. CO2 concentration measurement accuracy is provided for a range from 0 to 5,000 parts per million. Accuracy for readings above 5,000 parts per million is 10% of the reading, but not guaranteed since it is extrapolated from the calibrated range. The summary of the information about the CO2 accuracy measurements is visible on the screen. So now let's calculate the accuracy of the CO2 concentration reading that we have here. First I see that this reading is below 5,000 parts per million, so I will use the accuracy relation 3% plus 30 parts per million. So the reading says 640 parts per million. So first I need to calculate 3% of this value, which is 0.03 times 640, which is 19.2. But the resolution of this device says that I cannot leave any value after the decimal point, so I need to round this result. I feel that it is better to round up when talking about errors, so I will round this value to 20 parts per million. So the accuracy is this value plus 30, which is 50 parts per million. So what does this mean? If we look at the original reading, which was 640 parts per million, if we subtract the value of accuracy from our reading, we get the value 590 parts per million. But if we add accuracy to our reading, we get the value 619 parts per million. So our original reading says that the true value of CO2 concentration in this room is somewhere in the range from 590 parts per million till 690 parts per million. And this information holds true for 95% of the sensors. So there still is a 5% chance that the true value of the CO2 concentration is somewhere out of this range. Now let's look again on the sensor. The reading has changed a little since we have started our calculations. Now it says 636, but I still see that this value is somewhere in the middle of our range, so this change is not significant. So what I want you to remember from this video, that any measurement, and not just the one of the ARNet4 sensor, is liable to uncertainty. And the numbers on the screen don't give you the full picture of the measurement, and accuracy is a very important parameter that must be taken into account when measuring.